Good day to everyone. My name is Joyce Inyana Jos, and for today, joining me with our presentation today is Muhammad Najmi bin Muhammad Zaidi, Muhammad Shazani bin Zamri, and Muhammad Fahmi bin Saharuddin in Group 4. So, for today, I would like to start with presenting the process of our bridge design, which is a project that is required in structural analysis. So, for the bridge design, this is the 3D model that we have generated, which is from StatPro software. We have used StatPro software, which is a software that will automatically generate a design of a bridge that suits the output that we have chosen. So for the output, it is divided into two, which is the modeling and also for the loading. So for the modeling, we use universal column 305 times 305 times 2 at 3 millimeters, which is the dimension. So the length of the model will be 10 meters, the width and the height will be 2 meters and 3 meters. So for the design of the bridge, we have used the members of 22. Number of reaction will be 3 because the roller and pin support at each end. So for roller, we have 1 support reaction, while pin support have 2 support reaction. So 3. The number of joint will be 12. So if we input the equation of m plus r equals to 2j, here we will have find that the m plus r will be 25 while the 2j will be 24, which means that it indicates the 1 degree of indeterminacy in the internal side, which is internal redundant. So the design is statically indeterminate. For the loading, we put uniformly distributed load, which is as much as 2000 kg, which is equal with 2 tons along the bridge. If we take it into newtons, it will be 1.96 along the bridge. The E value of the bridge will be constant. Next, let's see the bridge elevation plan. So on the left side of the slide, the box number 1, you will see the 3D animation of the bridge. Next is the plan, the fronts and the side view of the bridge.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Shahmi bin Saharuddin. My street number is 88192017, and today I will be presenting the result analysis from the StatPro software. Okay, as you can see, here is our bridge model, and since there are all the forces to the y direction, there is no horizontal direction at the x direction. So the vertical and the y direction is both the same because this is a unit down and distributed load, and if we divided it and distribute this load, get 7.8 7.840. Okay, this is the value of the forces and the number of the beams here, and also the distance between the beam. Okay. Last but not least, the maximum axial forces. Okay, from the bridge that we have designed, beam 1, which is located at here, beam 1, it has the maximum axial force and x direction negative 0.428. While at the beam number 2, which is here, we can conclude that there is negative 0.272 at the beam number 2, and so on. Beam number 3, we got negative 0.272, same as the beam 2. Beam 4, 0.931. Beam 5, 4.613. Beam 6, negative 3.972. Beam 7, negative 5.325. Beam 8, 0.931. Beam 9, 4.613. It is a positive. Its mean it is at x direction, so it will be positive. go to the left lah. Beam number 10, negative 0.428 to the left. Sorry, the positive is to the right. Beam 11, negative 5.325. Beam 12, 2.305. Beam 13, negative 3.729. Beam 40, negative 4.121. Beam 15, 2.305. Beam 16, 5.156. Beam 17, negative 3.972. Beam 18, negative 4.121. Beam 19, 4.667. Beam 20, 4.667. Beam 21 and 22 both got the same, which is negative 1.027. I think that's all from me. Thank you.
Hi, my name is Muhammad Shazani and I'm going to continue our presentation with manual calculation for our bridge. So first, as usual, we are using equation of equilibrium to get the support reaction. So at the moment B, we get 7.84 kilonewton for FGY. Next, we are using summation Fy to get the same value, 7.84 kilonewton for FBY. So next, using method of join, at join B, we get 7.84 kilonewton at LB, and BC is 0 force member since the value is 0. At join C, we get negative 8.264 kilonewton for member CK, and negative 2.613 kilonewton at member CD. And then at join L, for member LC we get negative 8.264 kilonewton, and for member LK we get 2.613 kilonewton. For method of join, we use it only for this section, from at join L, K, B, C and D. Next, we are using method of section to get the value of these members. So to get the member KD, we get negative 7.84 kilonewton. Member DE, we get negative 5.88 kilonewton. Member KG, we get the same value, negative 5.88 kilonewton. As for member DJ and KE, we get the same value, 5.19 kilonewton. So that is for the calculation. For the calculation, we just do for half of the structure. Since the structure is symmetrical and the value of the support reaction is equal, which is 7.84 kilonewton. So we assume that the value of the members at the left and the right are the same. I think that is from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Najmi bin Muhammad Zaidi and I'm going to present for the conclusion and recommendation. First of all, to make our structure more stable, we should count the amount of beam used in the construction to be able to identify whether the structure of the bridge is statically stable, indeterminate or unstable. To make the structure stable, the total for the number of members and the total reaction of the structure, which is determined as R for reaction, should be the same as 2 times the value of its joint J. The structure should satisfy the equation of M plus R equal to J to be stable and not have external or internal indeterminacy. Not only that, it is crucial to calculate the compression and tension value of each member. The beam that have higher value of compression should be made thicker to prevent buckling. I think that's all for conclusion and recommendation. Thank you.